Hello, my name is Chris Gatehouse. I'm a Steel Account Manager for Tekla in the UK, and this video is intended to give you a brief demonstration of how we can build a portal frame in Tekla structures. So without further ado, we're going to get cracking. So I'm going to have a look at the grid first of all. So we double click on any aspect of Tekla structures to bring up the properties for any object, and that goes for views as well. So we double click on the grid to bring up the grid properties, and this is where we're going to adjust the spacings. So I can do it numerically, so I can say give me 4 grids at 6 meters with a span of 12 meters, and I want a level of 7 meters, and I'll just adjust the grid labels as well. You can see the values are highlighting yellow to indicate that I've got a value which has not been committed. And when I hit modify, they are committed. Okay, so there we go. Let's fit the work area to make sure it's all tidy. There we go. Straightforward. We can also do it using direct modification, so we can drag and drop these grids. That's no problem. But for accuracy, I prefer to use the values. So for column properties, we go up to the steel modeling tools. We double click on the column to bring up the properties on the right. And this is where we access the section library. So click on the ellipses button there, and we bring up the library. Now this is the UK environment. Other environments for other global regions are available. So we can go through here, and we're going into I profiles. I'm going to pick a UB section, so I'm going to pick a 356 and a 17145. So we pick that there, and we've got the same or similar library for grades. So we bring up that library, and you can see here under steel, we've got all of the steel sections. We've got the legacy ones here, the 43 and 50 for chaps as old as me who'll remember those. We've got stainless steel, we've got cold formed hollow sections, we've got some ferrous, and then we've got the mild steel grades along here. Further down, we've got concrete, timber, and miscellaneous. And miscellaneous sort of demonstrates the variety of objects and materials that you can specify in Tekla structures. It's not focused solely on steel and concrete. You can model anything made out of anything. It's entirely up to you. And I'll leave finish for now. So to put the columns in, you just pick the insertion point, in this case the grid intersection, and then it populates the model with the object. Now, for those who know portal frames, they'll see that that's in the wrong orientation, which is easily corrected. I can select the object, and using direct modification, I can go down to my mini toolbar, my contextual toolbar, and I can adjust the position by grabbing the green circle and rotating it around. Okay, there we go. And then I can just copy that around like so. Now in this demonstration, I'm going to use a popular shortcut, and that is to fully detail one bay, and then I'm going to copy it down the building just to speed up modeling. In order to do that, I'm going to create a 2D view on this grid line to give me a nice flat plane to work with. So I'll go along to my view tools using 2 points, set the plane on which I'm going to create the view. Now it has created it in 3D because I was lazy and didn't set the parameters here, but it's easily corrected using Control P to switch between 3D and 2D. I'm going to change the rendering level of the parts as well. So I'll just zoom in there using the Control and the numerical key shortcut. Now I'm going to put a rafter in, and I'm going to set it at a 6-degree pitch. Here's a handy little tip if you don't already know it. I'm going to use the along arc, create a point along an arc. So I'll start that command, I'll set the angle as 6, I'll apply that, I'll pick the center of that intersection there, and then a point along this line, and that's going to give me the wrong direction. So let's give that negative from here to here. Then I've got a 6-degree pitch, so I can include a construction line now, just so I can pick out the intersection with the grid line. Go to steel, go to beams, double click on that to bring the properties up, or I can load it manually this way. Steel beam, drop down, pick rafter, That'll load the rafter in. I'll leave it, actually I won't, I will increase it to a 457. Okay, and then I'm going to draw it from eaves to apex. Now, that might seem arbitrary, but there's a very good reason that I draw it from eaves to apex. If I turn direct modification off, you'll see, I'll explain why. So direct modification is off. You can see we've got a yellow handle which indicates the start point, and we've got a magenta handle which indicates the secondary point. Now the fabrication drawings will always orientate the parts onto the drawing with the start point, i.e. the yellow point, to the left hand end of the drawing. So it's good to bear this in mind when you're doing your modeling, to sort of think about the orientation of parts on the drawing page. So when I was an apprentice, I was taught to show the haunch on the left-hand end of the page. If you prefer your apex on the left-hand side of the page, then draw your rafters from the apex down. Okay. Turn direct modification back on. Now I don't have to draw that rafter again, although I can just mirror it. So if I right-click on the view, once I've selected the part, I can go to copy special, mirror, and then just define the line about which I want to mirror that part. It will populate the values, hit copy, and then I get a mirror copy. Okay. So we've got the basic geometry now of the frame. Let's look at some connections. So the first connection I'm going to look at is the base plates. So we're going to go over to the application component catalog, and we can find it in several ways. So we can start to search through the component catalog under the subcategories, or we can simply search for base, and that will return all of the base plate results. Now the one I'm looking for is this one, base plate, and it has a unique number, 1042, so you can search by those numbers as well. So if I put in 1042, you can pick that out. Okay, so if I double click on that, I'll open the dialog box for this component, and this is where you set up the parameters for your component. So we'll skip this first page and we'll go straight to parts, so we can specify a base plate thickness of 20. Don't worry about the width and the height, because we will specify that on the bolts tab. So under parameters, we will specify whether this base plate is being created with holes or bolts. We'll go across to anchor rods, and this is where you set up your anchor rods. So these top windows, values here are where you're setting up the details for the bolt assembly itself. So specifying the profile for the anchor, all that kind of thing, setting a grout allowance. This little collection of drop downs in the right hand side is instructing Tekla how to assemble, or the parts to include in the assembly of the anchor bolt. And then on the left here is the geometry and the setting for the anchor bolt assembly. Okay, but I won't touch on that just now. I'll show you that in the next step. Extra plates, also known as washer plates in the UK, and then your bolt array positions. Okay, so once we're happy with all of that, I forgot the weld tab, and we've got welds up here. Okay, once you've got all that set and you're satisfied with it, you can simply click on the application, or the component rather, to activate it, select the main part, and then the creation point down at the bottom here. Now that's running a DOS window. Once that's done, that took a little bit of time while it was running the command, but every subsequent connection is almost instant. So that the delay is only on the first created component. Okay. Now you can see what we've got here. Just to explain, this line here is what we call a fitting, and that's cutting that column. So at no point with any of the components within Tekla structures are you having to adjust the length of the main member. It does it automatically in the component using this command, using this object. Sorry, you've got holes in your base plate. The grey object represents the base plate, and then you've got your weld is shown as this cyan profile around here. You'll note that selecting the component object highlights the weld specification as well. And this green top hat here is indicating that a component exists. Okay, so that's sort of suggesting the intelligence exists. Once I've set a component and I apply it, that means that setting is stored. So every component that I create from this point forward uses those settings. We can also double click on that to bring up this window and change it as well. So we can modify the components so that they're different, or we can use presets. So these are a number of presets that come preloaded. So if I select type A and I load that in, this will give you the example with the holding down bar assembly built up as well. So if we go to anchor rods, you can see all of those parameters have been filled in. It looks complex. It really isn't that complex once you understand what all of these values are doing, and I won't cover it now, but you will pick it up. One thing to note here is this grout. So your leveling allowance is automatically taken off the length of the column if you put a value in there, and the grout is represented by the orange object there. The added advantage of adding that in is that once you've modeled everything, you can calculate by volume how much grout you need, for those of you who are calculating such things. Okay. So I'll just modify that one as well to make it match. And what I will do actually is I will change the weld specification to the base plate. So let's take out value 2, which is the flange welds. You can see this diagram here is indicating directly and correlating directly with these specifications. And I'm going to change this to an 8 all-round profile, like so. And you can see the weld changed within the window itself. So once I've got that, I'll go back to this one and I will modify that one too. There we go, we're happy with that. One thing to keep your eye on as well, I'll make this note now. When we come to the drawings, you'll see why. But under the General tab, you've got a value here called Connection Code. Now, if you're working with an engineer's calculation, for example, you could put the engineer's calculation reference in here. So I would typically call this BP1, base plate 1. So this is base plate calculation number 1. And you'll see why I'm doing that a bit later on we get to the GA. So just put a mental marker on that one. Okay, so we can come back up now to the eaves. Let me cascade these windows so that they are neat. So we can start to have a look at the eaves connection now. So if we go into our library again and I search for haunch, it brings up the haunch connections, and the one I'm going to use is eaves haunch. So I'm just going to use the default settings for this. So I'm just going to start that command by selecting it with a single mouse click, pick the column, pick the rafter, and I get a haunch. So we can have a look at that in 2D over here. So you can see what we've included straight away. We've got a compression stiffener between the flanges of the column. We've got an end plate. We've got a haunch. We've got our bolts. Okay, and it's automatically cut the top of the column level with the top of the rafter as well. The first thing to note with this is the haunch profile. This component will automatically match the haunch profile to the rafter profile. So if I double click the rafter, you'll see it's a 457191167. If I select the haunch, excuse me, if I select haunch, you can see that's matching. Okay, that is by default. That can be modified within the component window. What have I done? Right, double click on there, and you can see down here we can pick it from the library as before, but we'll leave it as it is. What it also is doing is cutting 2 from 1 automatically. So when you're working in this dialog box, when you go into parameters, you can specify the length and the depth of the haunch, but I recommend that you only specify the haunch length wherever possible, because Tekla will try to optimize your haunches to make sure that they are made 2 from 1. Okay, so if I change that now to 2 meters, you should see the depth adjust. There, it got a little bit deeper because the haunch got a bit shorter. So again, doing the 2 from 1. Okay. You can include other stiffeners too. So you can see in this window, we've got Morris stiffeners and rib stiffeners in here. So if we go into the parts tab, we can start to specify the thickness of those. So if Morris stiffener and rib stiffeners are specified as 0, if I give them a value, they'll be modeled. So if I put 10 in for the Morris stiffener, you can see we get a Morris stiffener like so. And if I put 10 in the rib stiffeners, we'll get rib stiffeners in between the bolts at the top of the haunch as well. Okay. If I take the Morris stiffener out, you'll see that the top stiffener will revert to a rib stiffener. All right. So there's quite a lot of flexibility inside these components. But for now, I'll take those out. For a cap plate, just change this specification. So let's have a full depth. Let's have a full cap plate like so. We can also change the specification for the top of the column within this component too. So we can say ignore the cut. So we ignore trimming of the column and leave it as set when we put it in initially, or we can square cut it to the top of the rafter here. And by default it's set as level, but I'll leave it a square cut with a cap plate. Okay. The final kind of important ones to look for are the bolts in the haunch and the rafter. You can set them independently. So I can say I want 5 bolts at 70 centers in the top, and at the bottom I want 3 at 80, like so. And then finally the welds. And again, similar to the base plate, you will see that we've got a diagram with all the welds numbered with corresponding lines for each weld. And we can just start to sort of populate this. So let's put an 8 on the top flange with the plate, and in the web we'll also have an 8. For the bottom flange, we'll reduce that, we'll put a 6. Weld number 3, which is the bottom of the haunch, again we'll put an 8 on that one. We've got if you were making this out of, if you're making a haunch out of plates, then weld specification 5 would be important, but that's not, because we aren't. Well, actually it is, because we're welding it to the end plate, so let's put that in as a 6. Number 6 with the web, we can put that in as a stitch pattern weld. So if we go along here, we can say we want a length of 150 and a spacing of 300, like so, which we just need to change this. So let's have a staggered, and you can see now we've got a staggered stitch weld there. And on the end of the haunch, which is number 7, we need to have a fairly robust weld. So let's say the 12, like so. And obviously that's going to be a single-sided, because you're not going to be able to weld inside that little gap there. So we'll put a decent weld on there. Okay. And then 8, 9, and 10 are your stiffener weld specs. But now that we've got that set up, we can either store that as a new default, like so, or we can just reproduce it. So select that specification, select the 2 parts to connect, and then we get the same connection. Okay. So moving on to the apex, again very similar. Let's pick the 2 parts, like so, and then we get the part in the model. Okay, again, double click on the component to bring up the dialog, and we can start to set it up. The difference with this one is that by default, the haunches are made out of plates. So you can specify those, or you can match it to the rafter profile, as we did with the haunch at the eaves. So put that specification in there, and you'll see the weld there has been removed, and then we can set that haunch up. So let's say let's try 600 deep and 1 meter long. Not enough zeros in there. That'll do. And again, you can just set this haunch up the same as very similarly to the eaves haunch, and that's sort of the similar. All these components are similar in the way that you specify them. Okay, so I'm going to leave it at that for now. You can see we've got our basic frame geometry. So I can select these 4 members now, and I can copy those either one by one, like so, or I can use a copy linear command. So I can select those parts, copy special linear from this point to that point. Now I know all these bays are the same size, and I want 4 copies down the building. So I can say copy 6 meters 4 times, and then we get our frame. Okay, wonderful. I'm just going to take a second to tidy this view up. I'm not a great fan of these tags while I'm working in the environment, so I'm just going to change that to no welds, just a mark, and that is slotted. There we go. Just tidies the view up, but I can still see the welds as these cyan lines. Okay. The next thing I'm going to want is some eave ties, so I'm just going to do that down 1 elevation first. So let's look at eave ties and bracing. So let's load this in. Let's load a beam in. Let's go for a brace, and a 114 is fine. So let's leave it at that. So I will go from the midpoint of that column top down to that one, and I'm being a bit lazy here, a bit of a shortcut. I'm drawing an entire line of ties, and you can see that's not lining through. So I can grab this end handle and I can pull that up to make sure they line through, like so. And then I'm going to want to, I'm not going to position that just yet. What I'm going to do first is decide how far down from the top of the rafter I want that. So there's often differing opinion on this depending on sort of who you're working with, who the engineer is, that sort of thing. So some engineers will want that on the intersection of the center lines. Some will be happy with that 100 mil down from the top flange. So I'll show you how to do both. So I'm going to use a construction line to draw a line across the top of that rafter, and then I can simply select that line. I can say move perpendicularly to the top of that rafter in that direction 100 mil. So I've got a line at 100 mil, and then I can move that bracing down to that line like so. Or I can pick an intersection, so create a point at the intersection of two part axes. So pick the column, pick the rafter, and I've got that point for me. So I can now move that line like so, down to there. Let's move that down to there, like so. Very straightforward. Something else I'm going to need is some rafter bracing. So let's figure that one out. So at the top here, I'm going to start by setting out my endpoints. So I'm going to create a projected point. Okay, and I'm going to set the projection as 200. I'm going to go down from here, down there 200, and I'll do the same thing up here, or down here rather. Go 200 up there, like that. And I'm going to want then sort of 3 braces. So if I go back into here, I can say create 2 points. Let's create 2 points along here. So that's my even spacing for my bracing. And I'm going to want to bring this up from there. So I will move these 2 points over to the next bay. So that's giving me my bracing setting out now. So I can go from this point to this point and just join it up. Okay, there, good and straightforward. Got nice even bracing. Well, that one didn't work very well, did it? Not paying attention to my snaps. There we go. Wonderful, wonderful. How about the vertical bracing? So very similar. So the one thing I do need is a view on the grid line that I'm trying to create that bracing on, like so. Again, change that to 2D. Change the rendering level using my shortcuts. And then I would like a split line. So create a point on a line, split once down that column. Let's go to the top of the base plate. There. And then we can draw that brace from here to here.